All right, last homework from chapter 11. I was feeling nice and only gave you one problem to do, and that was number 15. So this one is a long problem, so not really the nicest thing. Still had to do all the work. So let's look at number 15. So we have, as our inequality, x squared minus 6x is less than or equal to 91. So in class, we said we could graph both sides of the inequality separately and find where those two curves intersect. That's not fun, and we don't have any ways to algebraically solve this. Instead, we want a 0, just like when we solve for x. So to start cleaning this up, we should subtract 91 on both sides, so we get our necessary 0. So on this side, we get x squared minus 6x minus 91. We can try to factor this by hand. We're looking to two factors of 91 that add up to negative 6. So that's 1 and negative 91. 2 doesn't go in. 3 doesn't go in. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. 7 goes in. 7, that would be 7 times negative 12. Nope, negative 13. Does that up to negative 6? Yes, it does. So that is our winner. And I think the only other two pairs of factors would be positive 13 and negative 7, and then positive 91 and negative 1. So we just hit it on the second time. So we can write this x plus 7, x minus 13 is less than or equal to 0. So if we graph this, we don't need to because we already have our x-intercepts. So we really don't need to graph this, but instead we can use our number line method to do it a different way. So if we did graph this, we would get something like this, where it's a positive parabola, so we know it's going to look some... Ooh, and I missed that. Missed it again. All right. It'll look something like this, and we need to read the inequality. We want to know where this function is less than or equal to 0. So less than or equal to 0 is all of this space right here. So our function is less than 0 from here all the way to here. So we can see it graphically, but maybe you don't want to graph it. So we can use what we talked about in class, this number line, where we mark down our two x-intercepts, which here would be our first x-intercept would be the opposite of 7, so negative 7, opposite of 13, so positive 13. So we have negative 7, positive 13. We will be checking 1, 2, 3 intervals here. We always have one more interval than the degree. Our degree is 2. So we will have 3 intervals. What we're looking here is when will it be, and we want it to be less than or equal to 0. So we need a number to plug in. I'm just choosing the next smallest number than negative 7, so it's negative 8. If I plug negative 8 into this one, I get negative 8 plus 7, so that's negative. Negative 8 minus 13 is negative. So if I do a negative times a negative, I get a positive, and that is not in the solution set. A number between negative 7 and 13, I like using the smallest number possible, so 0. If I plug into 0 into the first part, I get 0 plus 7, so that's positive, and then 0 minus 13, that's negative, and if we multiply that together, we get a negative, and that is in the solution set. We have to check every single interval. So the next smallest number to the right of 13 is 14. 14 plus 7 is 21, which is positive. 14 minus 13 is positive 1, which is positive. And we do positive times positive, that's a positive. That's not in the solution set. So when we write our answer, it's asking on which intervals does this inequality have a solution. We need to say interval. So remember, we have inequality for intervals and interval notation with parentheses and brackets. So here for our inequality, we want x in the middle, and because we have these two numbers, we put the smaller number on the left, the bigger number on the right, and we always do our inequalities so the arrow points to the left. But we need to figure out, do we want less than or equal to or less than? And all we need to do is look at the original problem, even all the way up here, to see what symbol we have. We have the less than or equal to, so we need that in our answer. So there's one way to write our answer. The other way is with the interval notation. So if we have less than or equal to, that's a bracket. If we have less than with no equal to, that's a parenthesis. So since we have brackets here, we'll need two brackets. And then we always just put the smaller number on the left. So that's our way to do it in interval notation instead. So not actually that bad of a problem when we take away all that messy stuff that our notes and the examples from the worksheet had in it. So good luck.